Hi, this is Andrew. Thanks for joining me. This video covers subnetting from a binary perspective so that you can see what's actually happening when you're doing subnetting. This is part 2 in this series of videos. So if you don't fully understand binary, converting binary to decimal to regular numbers and binary back and forth, watch the first part of this video first. The understanding there is really important. So now what we're going to do is look at parts, what we do when we convert, when we subnet, or what a subnet means. So first step is we have 192.168.0.0. And now we can, and I will try to do this, and you'll see that it's not that easy because we just don't have a lot of space, but I'm going to convert this to binary. So 192 is 128 plus 64 is 192, and then we need 1, 2, 1, 2, 3, 4, and I'll put a dot. So 168 converted to binary, put a 1 in the 128 position, we subtract 128, we have 30 left over. So that's 0, 0, 1 in the 16 position, 30 minus 16 is 14, 1 in the 8 position, we have 6 left over, that's 1 in the 8 position, 1 in the 4 position, 1 in the 2 position, 0. And then we do dot, and 0 is easy, and then we do dot. Let's see, 1, 2, 3, 4, and dot 1, 2, 3, 4, 1, 2, 3, 4. So, too many. So this is that 192.168.0.0 in binary. Now, what does the /24 mean? That's the subnet mask. That's saying that our subnet mask is 24 bits long. So it's 1, 2, 3, 4, 1, 2, 3, 4, dot 1, 2, 3, 4, 1, 2, 3, 4, dot 1, 2, 3, 4, 1, 2, 3, 4, dot. Now that is 8 in each octet. So that's 8 plus 8 is 16, plus 8 is 24. That's our 24. That means now we do zeros. So this is this network address converted into binary. Now what does it mean? Well, it means that the first 3, any place there's a 1, that's part of the network address. Any place there's a 0, that's part of the host address. So we need to figure out the network address and the host address, and that's the whole point of subnetting. Now, in this case, it's really easy because it happens right on an octet boundary. So that means that the 192.168.0 is in the network portion, and I can highlight that in yellow, and the last part is in the I'll highlight in green, is in the network, is in the host portion. So the host portion is represented by the zeros in the subnet mask. Now what that means is what we normally need to figure out in networking is the network address, the broadcast address, the first IP address, and the last IP address. So in this case, we can look at this and say our network address, 192.168.0.0. The network address is defined as putting all zeros in the host address. So that's what we have here, and that's what we were given as a network address. Now, the broadcast address is normally what I'd like to figure out next, and in that case, that's putting all ones in the host portion of the address. So if I were to say broadcast, that is saying I'll put 1, 1, 1, 1. Oops. And let's get rid of a space here, and that is what the broadcast address is. And I'm only working in the last octet because everything else stays the same. 192.168.0 dot, and if we look at it, all ones in the host portion is .0.255. That's what we saw last time. If we add all of these numbers up, we get 255. Now that's the network, and now we have the broadcast. Now all we need is first and last. So first is the first number after the broadcast, and that is saying we're going to put I'll put them down here. First, last. So the first is just saying it's the first number we can have there. And in that case, 0, 0, 0, 0, 0.0.0.0.1. And that easily translates into 192.168 0.1. And last is 1.1.1.1.1.1. And we can't do a 1 here because that's our broadcast, so we have to put a 0 here. So our last is 192.168.0.254. Now, if you look at this, there are a couple of patterns we have. The network is all zeros. And if you remember from my last video, if you have a 0 in this last position, that has to be an even number. So that means that the network always has to be even. If you're doing some shortcut and you come up with an answer that says the network address is 192.168.0.1 or 0.129 or some other number, it can't be right. The network always has to be an even number. Now, the other side of that is the broadcast always finishes with ones in the host portion. And the host portion is always on the far right. So if we have, no matter what network we're looking at, the broadcast has to be an odd number. And the other side of that is, since the first is one more than the network and the network is even, the first is going to be odd. And since the last is one less than the broadcast, the last is always going to be even. So anytime you're creating a networking chart, if you don't see that pattern, you did something wrong. So now let's say I'm going to simplify this or reduce this down. Let's say we had a network that had, we don't need 254 addresses. So I'm going to remove the highlight on this. We don't need 254 addresses. We need actually, let's say, 4 networks. And we'll discuss this in other videos. But what we're doing here is we're saying, instead of putting a 1 right on the ones and zeros on the octet boundary, we're going to say we're going to steal 2 of these, sometimes called borrowing, and we're going to make this is going, ooh, it doesn't want to highlight right, so let's try this. This is going to be part of the host address, leaving only, no, Microsoft, I know what I want to do. Don't try to fix what I'm doing. There. So this is our new network, and basically we made that a 26 because now we have 26 ones here. So now let's figure out what all of these numbers are. Our network address, in this case, is still the same number, 192.168.0.0. So our broadcast, though, is not all ones because we're only working on these last 6 bits. So in this case, we had a 00. And the 00 is all in reference to, this 00 is the part of the network. So they have to be all 00s because we're not doing anything with that. Now, what we have is our broadcast is 111111, which is 32 plus 16 plus 8 plus 4 plus 2 plus 1. So in that case, 192.168.0 dot, everything 64 is off, so that means it's 63. And our network is 192.168.0.0, and our first is 192.168.0.1, and our last is 192.168, and that's this one right here, which is 32 plus 16 plus 8 plus 4 plus 2. Not plus that last one, so it's going to be 0.62, which again is one less than our broadcast. Now, that's great. That's one network. What if we want to look at the next network? Well, what we can do is we can say, let's turn the network, let's count this subnet by 1. So we change this to 1. That means that all of these get changed to 1. 1, and they should still be highlighted yellow because they are part of the network portion of the address. So this is our next network we have. And I'm going to just list it below. So the network address is 0100000 because we put all zeros in the host address. So that is the second binary position from the left. That's 64. So our network is 192.168.0.64 because this is our new network address right here. So that we're no longer using the that 0 up there. This is now 64, and we can follow the same pattern. I'll do first, I'll do last, I'll do broadcast. Now again, I normally do broadcast first, and you'll see why in a future video, but we do, our broadcast is all of these, which is 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, which is 127. So then we do our first, which is 192 plus 192.168.0 dot. Our first is this position here with a 1 at the end. So that's a 64 plus 1, 65. One more than the network again. Our last is 192.168.0 dot, and it's this one here, which is everything except that last one is turned off, so it's 126. Now we can keep going like this, and what I can do is I can say I'm going to now count to the next one, which is 1 0, because we were at 0 1, and if we count in binary, not what I wanted. If we count in binary, not what I wanted. There we go. If we count in binary, 0 1, the next thing after that, and let's make it bigger, is 1 0. So in binary, when we have these 4 bits, we have 0 0, which we saw earlier, and that's this network here. We have 0 1, which we saw here. Now the next one we're going to do is 1 0, and then we have 1 1. So these are the 4 networks we can create. When we take these 2 bits here and turn them into network bits, we can create 4 networks. We have the 192.168.0.0/26. We have 192.168.0.64/26. Next one we're going to have is let's see, with 1 0, we say that is, let's put it down here. That's our network is now 192.168.0 dot, and in this case, we have a 1 in the 128 position, so it's 128. Then, let's make things just a tiny bit smaller so we can fit it all on one page. Now we have our first, our last, and our broadcast. So in this case, we need to change all of these to match what we had there, which is 1 0, 1 0, 1 0. And if I highlight them, just to be clear, now what we have is our network is 192.168.0.128. So now for the broadcast, we do 1 0 1 1 1 1 1 1 1 1. And I'm gonna put those numbers in here so you can see them. 1 1 1 1 1 1. Now what we have here is just adding 128 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And we can say all of these add up to 63. So we're adding 128 plus 63. And that gets us to 192.168.0.191. Now that means our first 192.168.0.129 and our last 192.168.0.190. Again, we have our even number starting, we have our odd number broadcast, first and last, all makes sense. Now, if this was not easy for you, adding 128 plus, understanding why this is 63, it's really important that you do this by hand, that you actually either on, paper with pencil, or here you do 128, because you will not be able to do, you will not be able to get to any kind of conversion calculator when you're taking a Cisco exam. Network Academy, you shouldn't be using that. So just make sure you can do this kind of math in your head. And if it is not easy for you, practice. If it's been a while since you've done this kind of math, just the repetition of it will make it a lot easier for you. So now we're up to the last one. We have that 1, 1. Let's do the last network we have here. And we're going to put 1 there, 1 there, 1 there, 1 there, and I have 1 spot to fix. So now things get a little bit easier. I'm going to move these 2 out of the way. I will move them. I'm going to put them over here. So now we have our 4th network we're defining. And this one is going to be 192.168.0 dot, and we have 1, 1. And that means we're at this spot. 0, 0, 0. So we have 128 plus 64, which is 192. Which is 1 more than the previous broadcast. And that makes sense when we go through it. I'll do first, last, and broadcast. 192.168.0 dot, and our broadcast is all 1s, which we know is 255. So that means our first 192.168.0.193. Our last is 192.168.0.254. So we've just defined 4 networks, and now you know which IP addresses to use. Now, if you look at it, all we were doing was counting here. So the next one, we'll talk about why that works and apply it to other places, and how you can do this a lot quicker than converting to binary. So that's all I have for you today. Thanks for watching.